Okay, number 5 asks to find a relative minimum. To find a relative min or max, you want to find wherever derivative is 0, and that will give you the candidates for mins and maxes, the critical points. So f prime of x in this case is 6x squared minus 6x minus 12. We'll set that equal to 0. So factor out a 6, divide both sides of that by 6, and you get x squared minus x minus 2 equals 0. Factor that into x minus 2 times x plus 1 equals 0, and that gives you x is negative 1 and 2. So those are the two critical points. They could be the mins. Let's check and see. So here's our number line. Here's negative 1, and here's 2. And at those 2 points, f prime is 0. What about in between those points? The key observation is that in between these points, the sign of f prime doesn't change. It's going to either, if it's positive, it's going to stay positive, or if it's negative, it'll stay negative. So, because to change signs, it has to go through 0. So what we do is we pick a test point, let's say negative 2 in this first zone, and plug it into f prime. And we'll find that f prime of negative 2 is positive. So we just plugged f prime into, negative 2 into this expression. The answer is positive, so that gives us positive there. Then we'll pick a test point in this zone, say 0, in between negative 1 and 2. Plug 0 into f prime, and you get negative 12, which is negative. So f prime is negative between negative 1 and 2. And then plug 0, pick a test point to the right of 2, say 3. Plug 3 into the expression for f prime, and you get an answer that is positive. So that means that f prime is going to be positive for all values of x greater than 2. So the original function then goes up and then down and then up. The key observation is that there's a relative minimum at x equals 2. So the answer is C. Then for number 6, let f be that function. Which of the following is an equation for the line tangent to the graph? Okay, so for the equation of the tangent line, we're going to need a point on the line, and then we'll figure out the slope of the line. So for a point on the line, they say x equals 1, so the x-coordinate of our point is going to be 1. To get the y-coordinate of that point, just plug in 1 to the expression. And when you plug in 1 to this expression, you'll get 1 to the 5th times 2, so 2. Write that in there. 1, 2. That's the point on the line. And then we'll find the slope of that line. So the slope, what's the slope of that line going to be? It's going to be f prime of 1, the derivative of the function at x equals 1. So we'll find f prime of x. Okay, so we'll use the product rule for that. That will be 5 times 2x minus 1 to the 4th times the derivative of 2x minus 1, which is 2, times x plus 1, plus 2x minus 1 to the 5th times the derivative of x plus 1, which is just 1. So that can simplify down to 10 times 2x minus 1 to the 4th times x plus 1 plus 2x minus 1 to the 5th. And so then f prime of 1 is going to be 10 times 1 to the 4th times 2 plus 1 to the 5th, which is 21. So then the equation of the tangent line is given by the point 1, 2 and the slope 21. Using the point slope formula, y minus 2 is 21 times parentheses x minus 1. And then we'll just solve that for y. So we get y minus 2 is 21x minus 21, which gives us y minus 2, or y is equal to 21x minus 19, choice B.